Hello friends, welcome to my channel. Next problem 1.14. Figure shows tracks of three charged particles in a uniform electrostatic field. Give the sign of the three charges. Which particle has highest charge to mass ratio? Okay, this is the diagram. Here it is given, it is along the x-axis, it is y-axis. So we need to find out the answer for this question. So first we have to know what is the meaning of this question. So what is the meaning? In this figure, they are given the track of three charged particles. First 1, 2, 3. These charged particles are moving in this uniform electric field. So they are to be deflected. Okay, so we need to find out the sign of the charges. Next we need to find out the charge to mass ratio. Okay, so easily we can find out the sign of the charges, because what here it is a positive plate, here it is a negative plate. That means which charge will be deflected towards the positive plate? That is negative charge. So the first charge is a negative, second charge also a negative, and the third one is deflected towards the negative charge, so it is to be a positive charge. Next we need to find out the charge to mass ratio. For finding the charge to mass ratio, we have to consider a situation. Okay, so here it is a positive plate, here it is a negative plate. Here is the x-axis, y-axis. Here a plus 2 charge, it is moving along the direction of x-axis. So this positive charge is deflected towards this negative plate. Okay, so we need to find out how much it is deflected. We need to find out. Okay, so mathematically this is moving along the x-axis, so the Vx is V, that means x-axis velocity V. What about the y velocity? That is the initial velocity will come. So Ux, that is Uy. Uy is equal to 0 because it is going parallel to the x-axis. Clear? Okay. Here there will be an electric field along the y-axis. So this charged particle will experience a force. That force F is equal to QE. Okay, and based on this we know F is equal to MA. Based on the second, equate these two. So from this what we'll get? QE is equal to MA. From this acceleration A is equal to QE by M. That means this acceleration is along which direction? This electric field is along the y-axis. So force is along the y-axis. The force is to be along the y-axis, acceleration also along the y-axis. So this acceleration is along the y-axis. So is there any acceleration along the x-axis? No. The acceleration along the y-axis is QE by M. Acceleration along the x-axis is 0 because there is no force acting on the x-axis. Okay. Then next, so there is a force is acting on the y-axis. So what is the displacement along the y-axis? I'll find out. This is the displacement. So this can be found out by using which equation? Motion equation. Here the acceleration is Q is constant, E is constant, M is constant. So we can apply it. Okay, so S is equal to ut plus half at square. If SI will be considered as a y is equal to uy t plus half into ay t square. Okay, here uy is equal to 0. Okay, so we'll get it as half into ay. What is the ay value? QE divided by m t square. Okay, then from this I am finding the q by m. What is q by m? We'll keep q by m here, remaining all come here. This 2 will come here, multiply. So y into 2 divided by et square. Here E is to be constant, T is to be constant. So Q by M is directly proportional to Y. Q by M is directly proportional to Y. That means the deflection. So if Y deflection is larger, the Q by M is to be larger. This we will apply in the case. Okay. So here you can see that the deflection, along the y-axis deflection here, the first second is smaller compared to the third. You can see that the deflection in the third charge is larger. So the Q by M of the third charge is to be larger. So the highest charge to mass ratio is for third particle. Thank you for watching the video. Please subscribe my channel. If you like this video, please put like